Well, I was discussing about the interpretation of this coefficient table and this collinearity diagnostic. I have told that you need to see the VIF value of each variable. If you see the VIF value of final variable, you can see that the VIF value is less than 10 and its tolerance value is greater than 0.10. So we can say that there is no issue of multicollinearity for final variable. But if you see the total and percent variable, you can find a VIF value greater than 10, and you also find a tolerance value less than 10. So we can conclude that there is a multicollinearity issue between total and percentage. So basically the procedure is that either you need to increase your sample size or you need to transform any one of these variable like total or percentage, or you can also remove one of these variables. So how can we decide which variable we need to remove from here? There is a very simple procedure. If you go to the collinearity diagnostic, you can see that the fourth one uh, for eigenvalue is the value which is closer to zero, because if you convert this number using your calculator or using your Excel sheet, this value becomes very closer to zero, and the third value is also closer to zero. uh, but when you see the condition index, it is showing the first three, like 2, 3, and 4 row greater than 15, and then you can verify the variance proportion, and you can find out that there are two numbers. Like you can find out the value of final, the various proportion of final is greater than 0.90, and you can also see the variance proportion of the total marks is also greater than 0.90, and the highest one is percentage, which is greater than 100. So you may preferably remove basically the percentage mark. So whenever you remove this number, because it is showing the highest ever variance proportion, so you can remove this number, and you can retain the final and total. So this is the way you can deal with multicollinearity. So this number, the percentage marks, is basically the mainly causing the multicollinearity. If you still find the multicollinearity between final and total, you can then remove the total marks. So this is the way how you can deal with multicollinearity. So next is, after doing this, you need to understand how what are the measures do you have if you find multicollinearity in your data. What you need to do, what are the remedial measure that you need to use when you find multicollinearity in your data? The first thing is mild multicollinearity. It means it is not perfect, or it is not linear, or it may be weakly significant correlation. Then we may state as a mild multicollinearity. So in case of mild multicollinearity, you don't need to do anything. So how can we find out whether there is a mild multicollinearity? If you can see, there is a value which is less than 10 but greater than 5. Like if you can see, the value of the VIF value of quiz 3 is greater than 5 but less than 10. And you can also see the value of quiz 1. The VIF value of quiz 1 is also greater than 5 but less than 10. So we can consider them as a mild multicollinearity, but still they are ignorable. So in the case where you find the mild multicollinearity, you don't need to do anything. Next is perfect multicollinearity. How do you find the perfect multicollinearity? The criteria is VIF greater than 10 and tolerance level is less than 0.10. So whenever you find VIF greater than 10 and tolerance level less than 0.10, it is a perfect multicollinearity. So what we need to do in case of perfect multicollinearity, you can only forecast the data. If you are trying to predict your dependent variable on the basis of independent variable, you can still predict your data, and you don't need to remove the variable. The second option is if you have perfect multicollinearity and your sample size cannot be increased due to time and cost, like I have previously stated, then still you don't need to do anything, because it is a constraint, it is a limitation that you cannot increase your sample size. It is basically the data deficiency issue. Multicollinearity is a data deficiency issue. So whenever you are able to increase your sample size, it will automatically remove from your data. But if due to any reason you cannot increase your sample size, then it is your limitation of the study. Then you don't need to do anything. You need to carefully interpret your relationships that you have found. Next is perfect multicollinearity. Perfect multicollinearity is not a problem if theory permit us to estimate the missing coefficient. So if theory permit us to estimate the missing coefficient, we need not to do anything but to drop one of the independent variable causing the multicollinearity. Like I have explained you in our case, that there is a multicollinearity between total and percentage, which is high multicollinearity. And we find out the one which is causing more multicollinearity is basically the percentage variable. So we need to remove this variable. So the one which is causing more multicollinearity may need to be removed. So you can adjust your solution over here, that not a problem if theory permit us to estimate the missing coefficient, do nothing but drop one of the independent variable causing multicollinearity. The next process is perfect multicollinearity. Multicollinearity found between two independent variables. So if multicollinearity is found between two independent variables, drop the less significant, drop the one with larger variance inflation factor, or do not drop the variable if the theory make this variable compulsory to include in the model. So if your variable is compulsory and the theory does not permit it to drop, then you need to retain it. Then if you have perfect multicollinearity, you can still transpose your variable, transform your variable. You can combine some of the variable, like if you have import and export, you can combine them and create a new variable like openness. You can create a net variable of the two, you can consider import minus export as a net export variable. You can take the log of the value, you can take the first difference of the values, you can divide the variable by appropriate measure, like real rate is equal to nominal rate divided by inflation. So your measurement may also change uh, the multicollinearity issue. Then if you have perfect multicollinearity in case of time series data and cross-sectional data, combining the time series and cross-sectional data make it into panel. So considering the panel data will also control the multicollinearity issue. So whenever you find multicollinearity issue in your survey data or in your cross-sectional data or in your time series data, try to convert it into panel data. So panel data basically controls the multicollinearity issue. Then if you have perfect multicollinearity, you may use rigid regression or factor analysis to find out which factors are basically causing the multicollinearity issue. So these are the remedies that you can apply if you ever find the multicollinearity in your data. Next is basically the fifth assumption, that is testing the assumption of outlier. First, you need to understand what outlier is. Outlier is basically a point which is deviated from the central points. So whenever you find some value which is deviated from their majority of the central value, like if you can see in the above measurement scale, you can find that there are some values which we can find between 1 and 5, and there is a value which is approximately 9.5, and it is away from majority of values. So this value which is away from the majority of value, we can consider it as a outlier. So why we are finding the outlier? Outlier basically make our result inconsistent. So in order to make the result consistent, either we need to remove the outlier or we need to make the corrections that why this outlier has appeared, sometime due to data entry issue and sometimes due to wrong measurement method. So we need to identify that if there is a outlier in our data set or not. So what is the outlier? An outlier is an observation or data point that deviates significantly from the rest of the data in a data set. So in other words, an outlier is an observation that lies abnormally far away from the other values in a data set. So outliers can be problematic because they can affect the result of an analysis. Then what is the assumption? The assumption is there should not be a significant outlier in the variable of interest or data set. So you need to identify whether there is an outlier and whether that outlier is significant outlier or not. So that is an important issue. So how can you identify the outliers? How can you detect the outlier of your data? There are a number of ways through which you can identify the outliers of your data. If you have categorical data or Likert scale data, you can identify the outliers of your data using frequency method. It is a method that you can apply using descriptive statistics. So if you have your Likert scale variables or your Likert scales data or categorical data, and you want to find out the outliers, you can use the frequency method. In the other cases, and still with the categorical variable also, and with the continuous variable also, you can use the explore method or standardized value z score method. In the explore method, you need to go to analyze, descriptive, and then explore, put your variable of interest in DB list, click on statistic and check box for outlier. It will show you dots in below or above box plot with the number of observations having outlier for the variable of interest. Then there is a third method which is known as standard value z-score method. You can apply this method using analyze, descriptive, then descriptive, put your variable of interest in the relevant box and check the save standard value as a variable and press OK. Now go to the last column of your data view, which is showing the z value of your variable. Just right click and sort descending. If you find any value greater than plus 3.3 or minus 3.3, it is an outlier that need to be corrected. So these are the three methods. Let's try them one by one. I will show you how they can be applied. The first method basically require the categorical or scale data. So let me check whether I have the scale data or not. The data set which is open in front of you is basically the non-scale data. The scale data means the data with Likert scale. So let me check whether I have available the Likert scale data or not. Let me check. think there may not be a Likert scale data available, but I need to see these variables for these data sets. Maybe I have the Likert scale data. Still, this data is also showing uh, pure quantitative data, and you can see some values over here. Let's consider like reverse one. as our Likert scale data. You can see the values ranging from 1 to 7. So let's suppose this is a Likert scale data. So how can we apply the first method of detecting frequency distribution or detecting the outliers? So let's suppose I am applying the frequency method over here. I need to go to the analyze descriptive statistics, then I need to choose the frequencies, and I need to put my Likert scale variable. If you cannot identify over here, just right click and this option will appear. You need to check the first option and it will consider the variable formation of the data. So let's suppose H control 1. I will have to see H control 1. This is H control 1. You can put it here. You can also put H control 2. And I think we should see both of them. You need to go to the statistic and you need to check minimum and maximum from here. Then continue, then click OK. And you will find some tables like this. You need to see the minimum and maximum of your data. So let's suppose the minimum number is 1 and maximum is 7. So you need to verify if uh, the data having a number which is entirely different from minimum or maximum. So we can conclude here that this type of data does not have any outlier in the data set. Let's suppose, for example, if I have a number, uh, let's suppose here I have a number 17, let's suppose. Okay. Then how can I identify it as an outlier? Go to the analyze, go to descriptive, go to frequencies. Again, I will run it and you can find here the minimum and maximum range, and you can see here there is only one observation with 17. So if you find any value which is below the range or above the range of your data, that number would be your, uh, you can say, your outlier. So in this case, in our first variable, there is an outlier of number 17. So this is basically the outlier, how you can identify the outlier in your data, or how you can identify the outlier in your scale data, or 5-point Likert scale or 7-point Likert scale. The second method is explore method. How can you apply it? You need to understand the whole procedure. I will let you know. I will use this data for explaining this procedure, but first you need to be aware of the data in order to understand that what is this procedure. So let's suppose we want to apply the explore method for detecting outlier, and suppose we have income data in thousands of 15 individuals, sorry. Like for individuals one, we have $18,000, we have $24,000 for second individual, and for third individual we have $26,000, and so on. So I have used their exact number as their data. So how can we analyze this data? You need to go to analyze tab, then descriptive statistic, then explore. In the new window that pops up, drag the variable into the box labeled dependent list, then click statistic and make sure the box current to percentile is checked. Then click continue, then click OK. If there is no circle or asterisks on either sides of the box plot, this is an indication that no outlier are present. So how can we apply this procedure? You simply need to create a new data set over here. So because the data of this example is not available, and there are only 15 values, so I can prepare a new data set over here by just putting the values. The variable name is income, just need to click over here and consider it as a scale variable, and you need to put the values over here. What are the values? That is 18, 24, 26, 18, 24, 26. The next value is 34, 38, 45, 34, 38, and 45, 35. The next value is 48, 54, 60, 48, 54, and 60. 40. Then we have 73, 79, and 85. 73, 79, 70, 94, 98, 108. 94, 98, 108. Yes. So we have this data set, let's suppose, and we want to analyze the outlier using the second method, which is explore method. So how can we do this? You need to go to analyze, go to descriptive statistic, and you need to select the explore button. It is located over here. You need to click this. You need to put your variable into dependent list. Then you go to the statistic. You need to check the percentile only. Click continue. You don't need anything from here. You can uncheck all other options. You need not to do anything from here. You just need to click OK, and you will find the data like this. So what you can see over here, it will generate three outputs. The first output is descriptive. We does not needed the descriptive statistics over here. We can see three things, and we need to check the percentile table, and we need to check the box plot table. This is box plot table, sorry, the box plot image, and you want to see the percentile table here. So what we need to see over here, you need to see that the box plot does not contain any you can say circle in the above side or in the lower side. This is basically the first quartile, this is second quartile, and this is third quartile. So if you find any circle below the first quartile, or you find any circle above the third quartile, this may be a potential outlier. So in this case, we do not have any outlier. You can also see the percentile score. This is basically Turkey's hinge values. Uh, you can see that 36 is basically the first quartile score. It is appearing on the 25th percentile. So it is first quartile score. This is the score of this area, this first quartile area. So you can see 54 as a second quartile. This is the score which appears in the middle of this line. This is basically the second quartile area. And you can also see the third quartile value which is 82. So this value appears on this. So you can say that a value a value which is above the third quartile or below the first quartile would be considered as a outlier. So how can we understand the concept of the outlier here? You need to see some of the important consideration over here. I have applied the procedure, and I also put it all the screenshot over here. Just you need to learn one thing more, and you will understand the procedure. I have told you that uh, this is your first quartile, this is your second quartile, this is your third quartile. And from the picture, you have identified it as a first quartile, it is as a second quartile, and it is as a third quartile. So what you need to do, if you see the text I have written over here, I have mentioned that SPSS consider any data value to be an outlier if it lies outside of the following ranges. So what is the range? If you see the third quartile plus one-fifth of the interquartile range. So what we consider interquartile? If you subtract the first quartile from the third quartile, you will obtain interquartile range. So when you put a third quartile value over here, then you add one-fifth of the interquartile range, and you will find out a value that may be a potential outlier, yeah, or the value above that value would be the potential outlier. In the same way, you may find out the potential outlier in the first quartile by subtracting the first quartile by subtracting one-fifth of interquartile range from first quartile. So you can find out in this way how the quartiles would appear. So I have find out these three values from the table, and we can calculate the interquartile range by taking the difference between the 75th and 25th percentile in the row labels Tucky hinge in the output. For this data set, the interquartile range is 82 minus 36. I have told you that you need to subtract the first quartile from the third quartile. So 82 minus 36 is 46. 46 is basically interquartile range. So what you need to do, you need to take one-fifth of 46 and you need to add into 82. 82 is basically the third quartile value. So when you calculate these, it will equals to 151 for the third quartile range. And in the same way, 46 multiplied by 1.5, whatever the value would be, you need to subtract it from the first quartile and you will find minus 33. Obviously, income cannot be negative, so the lower bound in this example is not useful. However, any income over 151 would be considered an outlier. So we need to consider that 151 is the range of this data. So if we put any value greater than 151, it would be considered an outlier. So let's suppose we put a value 152 as a 15th value in the data set. Then we will generate this as a outlier, and outlier will appear like this. So I can apply this procedure uh, in front of you. Let's suppose it is our 15th value, and we can replace uh, how much number we can replace 152, because I have told you 151 is the maximum range of your data. So you can put any value greater than 151. So we are putting 152 as a value, and in the 15th value, because we have 15th values over here, so we can put here 152 as our possible number. Now I will analyze this again, and by doing this, you need to go to the descriptive and then explore, and then you need to put income. Still we need to confirm that percentile is checked, and you need to click OK, and you will find something different from the previous one, and you can see there is a number 15 that is locating over here. So this number is basically appearing with a circle. So it indicates that there is an outlier, but it is not an extreme outlier. It is just a simple outlier. It will not influence our results. So it is a simple outlier over here. So if we can see over here, this is insignificant outlier, like I have already stated to you. This 15 number, which is showing just a circle, it is an insignificant outlier. So when it becomes significant, if it is appearing with a star or with a steric, it will become significant. And a significant outlier would be an area of concern for us. We need to identify how much is the significance of this outlier. So we need to check whether there is a significant outlier or not. So how can we identify? We need to calculate our quartile again because our quartile has changed. You can see in actual results, as I have changed the data, the quartile result has also changed. You can see in the percentile result, the Q3 is 82, the Q3 is 82, the percentile is 54, and Q1 is 36. So you need to recalculate your percentile, and you will find a value different from the previous one. When you find again uh, the maximum value is 220. So for example, suppose the largest value in our data set was 221. So if I put this value in my data set, instead of 152, I need to put 221. I need to check. Yes, 220 is the maximum range. I need to put 221. So when you put 221, you need to reanalyze your data, and you will find you need to click OK, and you will find a result which is entirely different from the previous one. Now you can see a star with 15. It means that there is a potential and significant extreme outlier present in our data set, and it can influence our results. So this is the way you can identify uh, your potential outliers in your data set. Can you hear me, everyone? There was an interruption of internet. That's why I could not be able to talk for a minute. So can you hear me, everyone? Please let me know. Just send a message. Please let me know if you people can hear me in a message box. Hello. Hello. All right. Someone has sent message. Oh, all right. Excellent. All right. Okay. I have told you that we need to check this one, and I was explaining the concept that whenever you find a number above the third quartile or below the first quartile with an asterisk sign, it means that you are it means that you are dealing with an extreme outlier. And in case of extreme outlier, if that is present in the data, the number which is indicated with that outlier is basically the number of observations that you need to either correct that uh, uh, number, or you need to basically remove it. So there are two ways that you can deal with your outlier. The first method is either you can remove it, but if your sample size is very small, like there are only 15 numbers here, you can also take the average of this value. You can also find out the average of this value. But in case of large data set, you can remove it. You can simply remove this value, and you can assess the remaining value. But in case if the sample size is very small, you need to take the average of remaining value, which is the average method that I have discussed with you in case of missing data analysis. So this is the way how we can deal with outliers. So it was the second method that you can apply while outlier detection. I have told you uh, there are three methods. The first method is frequency method, that is basically applied on Likert scale data. The second method is explore method that I have told you right now. And there is a third method, which is standard value z-score method. Uh, so how we can consider this method? It is basically analyzing descriptive, then put your variable of interest in the relevant box and check the save standard values as a variable and press OK. So you need to generate the Z value of your variable of interest, and you need to find out by a descending order that the highest value, whether it is positive or negative, the highest value should be less than these range. If the value is greater than 3.3 or minus 3.3, it means there is an outlier. So I will elaborate this procedure, how you can apply. So you need to go to analyze, then descriptive, then again you need to go to descriptive. So for example, if we are using this data set, I need to go to analyze, descriptive, again descriptive. I need to put a variable of my interest. For example, I want to see the percentage, or you can also see the total marks. For example, you need to put the variable of interest in the variable box, and then you simply need to check this option, save standardized values as a variable, and then you need to click OK. So whenever you generate it, you need to see the last column of your data. You can find out here